Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2183, refers to an ECT, Engine Coolant Temperature Sensor 2 circuit range or performance problem in Honda Civic models from 2006 to 2011. This specific issue suggests that the ECT sensor is either malfunctioning or not providing accurate temperature readings, which are crucial for the engine's performance and efficiency. The ECT sensor's main role is to measure the temperature of the engine coolant, providing necessary data to the Engine Control Module, ECM, or Powertrain Control Module, PCM, to adjust fuel injection and ignition timing accordingly. In the Honda Civic, ECT Sensor 2 is typically located near the engine, often on the cylinder head or the upper radiator hose connection. When this error occurs, the engine may run inefficiently, possibly affecting fuel consumption and emissions. DTC P2183 signifies a malfunction in ECT Sensor 2, which is responsible for monitoring the engine coolant temperature. The engine coolant temperature is essential for the optimal functioning of the engine because it impacts fuel efficiency, emissions output, and overall engine performance. ECT Sensor 2 is typically positioned in a location that allows it to accurately gauge the temperature of the coolant flowing through the engine. If ECT Sensor 2 fails or provides inaccurate readings, this can lead to improper fuel mixtures and ignition timing, ultimately harming the engine's performance. The ECM relies heavily on accurate data from this sensor to make critical real-time adjustments to various engine functions. When diagnosing DTC P2183, several possible causes should be considered. One key issue may be poor connections at the ECT Sensor 1 or ECT Sensor 2. These connections may become corroded or loose over time, leading to erroneous readings. Another possibility is a faulty ECT Sensor 2 itself, which may not function effectively, thus providing inaccurate temperature readings to the ECM. Additionally, damaged wiring or terminals can potentially interfere with the sensor's functions, leading to performance issues as well. Understanding these possibilities can help in narrowing down the root cause of the DTC set by the vehicle's diagnostic system. When experiencing issues related to DTC P2183, drivers may encounter several symptoms that indicate malfunctioning engine coolant temperature readings. One common symptom is engine misfires, which can occur due to improper fuel-air mixture adjustments by the ECM based on incorrect temperature readings. Additionally, poor fuel economy may be evident, as erroneous temperature data could lead to inefficient combustion in the engine. Increased emissions might also be noticeable, as the vehicle could emit greater levels of harmful substances if the engine is not operating optimally. Observing these symptoms can assist in diagnosing the underlying issue linked to DTC P2183 and facilitate timely repairs. The first troubleshooting step for DTC P2183 involves checking for poor connections or loose terminals at both ECT Sensor 1 and ECT Sensor 2. It's essential to visually and physically inspect these connectors and wiring for any signs of corrosion or damage. Ensure that the terminals are secure and are properly seated, mitigating the risk of any intermittent connection issues. If these connections are found to be in good condition, this indicates that the sensors themselves may be at fault, warranting further investigation. Conversely, if poor connections or loose terminals are discovered, repairing or replacing them as necessary will be crucial before moving on to subsequent diagnostic steps. For the second step in troubleshooting DTC P2183, turn the ignition switch to the on-to position without starting the engine. This action powers up the vehicle's diagnostic systems and allows for the use of the Honda Diagnostic System, HDS. Utilizing the HDS, check for any pending or confirmed diagnostic trouble codes that may provide relevant data. Particularly, look for DTCs like P1116 in conjunction with P2183. If these codes appear together, it suggests a specific failure that will need addressing. If none of these codes are present, proceed to the next step of troubleshooting to delve deeper into the ECT sensors. In this third troubleshooting step, start the engine and allow it to idle for a duration of 10 minutes. This idling time is crucial, as it gives the engine a chance to reach operating temperatures, enabling accurate sensor readings. With the Honda Diagnostic System, monitor the value recorded by ECT Sensor 2 during this idle period. The expected reading should be around or below 131 degrees Fahrenheit, 55 degrees Celsius. If the value aligns with this expectation, then the ECT sensor's ability to provide accurate data appears functional. However, if it exceeds this temperature, further diagnostics will be required, leading to a possible sensor replacement. The fourth troubleshooting step requires turning the ignition switch to the lock, 0 position, to shut down the vehicle's electrical systems. After doing so, allow ECT Sensor 2 to cool down to the ambient temperature. This cooling period is critical as it establishes a baseline temperature needed for the next check. Once the sensor has cooled completely, carefully note the ambient temperature to ensure that it can be used as a reference point when checking the ECT sensor readings later. This methodology is vital for verifying sensor accuracy and identifying any discrepancies that might indicate failure. For the fifth troubleshooting step, turn the ignition switch back to the on/2 position again. Quickly check the value of ECT Sensor 2 using the Honda Diagnostic System. It's essential to compare this value directly against the previously noted ambient temperature. The difference should ideally be less than 5.4 degrees Fahrenheit, 3 degrees Celsius. If the ECT sensor's reading shows a larger discrepancy, it indicates that the sensor may be faulty and could require replacement. However, if the difference is within range, it suggests that the sensor is currently operating normally, but may have intermittent issues, requiring further investigation into connections or wiring. The sixth step in the troubleshooting process involves revisiting the connections at both ECT Sensor 1 and ECT Sensor 2, as well as examining wiring that connects to the Engine Control Module, ECM, or Powertrain Control Module, PCM. Inspect for any loose terminals, damaged wiring, or corrosion that might interfere with signal transmission. This stage is crucial because poor connections can lead to intermittent issues that are not always evident during initial checks. If you discover any problems during this inspection, rectifying these issues could resolve the DTC P2183 without requiring sensor replacements, saving both time and costs associated with parts. The final repair verification step entails clearing the DTC from the vehicle's memory once repairs have been made. After clearing, cycle the ignition to the on position, allowing the vehicle systems to restart. Conduct a test drive under various driving conditions to ensure that engine performance is stable and that no warnings or check engine lights reappear. Monitor readings for any signs of trouble or codes that may recur. Successful verification will demonstrate that the issue has been resolved, confirming that all related components are functioning correctly and that the root issue linked to DTC P2183 has been effectively addressed. Preventive maintenance is vital for avoiding future issues related to DTC P2183. Regularly inspecting ECT sensors and other related components can catch potential problems before they escalate. Ensuring that all connections are secure and free from corrosion will significantly reduce the likelihood of experiencing issues tied to poor electrical signals. Additionally, addressing any coolant leaks promptly will prevent issues that might affect the ECT sensors and their capabilities. By maintaining these preventive measures, the longevity and reliability of the vehicle's performance can be greatly improved. In conclusion, understanding the role of the ECT sensor is critical when addressing DTC P2183, as this component is integral to efficient engine operation. Systematic troubleshooting emphasizes the importance of checking connections and verifying sensor performance through various steps, aiding in accurate diagnosis and repair. Following through with the structured diagnostic approach provides clarity on where problems may arise, which can prevent unnecessary part replacements. Moreover, engaging in preventive maintenance plays a significant role in avoiding future issues, thereby extending the vehicle's life and maintaining optimal performance. Consistently applying these principles equips technicians to better handle similar DTCs in Honda Civics and other vehicles in the future. Please like and subscribe to the channel. See you next time.